All right, here we go. Back for another page or two of notes here. 2 pages of notes to be more specific. So again, going back to the hypothesis test, we have to figure out what our hypotheses are. We're going to have a null hypothesis. Okay, so the null hypothesis is going to be the mean is equal to some number. Your alternate hypothesis is going to be, therefore, the mean is going to be greater than that number. The mean could be less than that number, or my mean could be not equal to that number. Okay, so remember, we're testing if it's greater than, we're going to go to the right. If it's less than, we're talking about left. And if it's not equal to, we're going to have an area on both sides of the curve. So we'll have to double our area if that comes into play. We're going to use our calculator, so probably isn't too big a deal. Anyway, an MHS psychologist reports that the mean number of hours the students at this school sleep each night is 7 hours. After observing students falling asleep in her class, Mrs. Sapp questions that claim. She believes the true number of hours MHS students sleep is less than 7 hours. To find an estimate of the true mean, Mrs. Sapp selects a random sample of 35 students, MHS students, and records how many hours each slept the prior night. The sample mean is 5.67 hours with a standard deviation of 1.88. Test the claim using a one-sided hypothesis test. Use the level of significance at 0.05. And I just realized that I forgot to make you draw the curve on the other one, but that's okay. So again, our parameters necessarily is not, we're going to list the population parameter because we'll do that when we get to hypothesis. We're going to list out all the different things that we're going to use here. The first number that we came across was 35, so my sample size is 35. The next number we hit was sample mean of 5.67. So that's going to give me an X bar. We have an SX, would be my sample standard deviation. Sample standard deviation is 1.88. Okay, so we've listed everything we need to there. H, again, refers to your hypotheses. And you don't have to follow the phantoms. You could just use that to double check, but I guarantee you it is so much easier to grade your test if you just put it in that format, because we can just go check, 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 check. Don't have to hunt, don't have to anything. So when we're stating our hypotheses, we're going to have a null hypothesis. That null hypothesis is a statement of equality. We're going to test this against the psychologist's claim of 7 hours. Okay. Our alternate hypothesis is going to be what we're testing against. Mrs. Sapp thinks that because everybody's fallen asleep, that has to be less than 7 hours. So that's going to be what I'm going to test that against, less than 7 hours. And now that we introduced that variable, that population mean, we're going to go mean mu is the true mean number of hours slept each night by MHS students. Okay, so our hypotheses are off the list. And in reality, again, sometimes I do a poor job at this. When we first read this, we have one sample that we're working with. We do not know what the population standard deviation is, so we could run right to our test and name that first if you wanted to, but we'll just go in order of phantoms here. Anyway, we have our assumptions. Remember, our first assumption is we have to have a random sample of my population. So in this case, we need a random sample of MHS students. Okay, and that was stated. Next one is, I'm going to in order to do this hypothesis test, it has to be approximately normal. Okay, and remember, approximately normal, we have to have our way. We have to start being able to delineate when am I going to use n times p is greater than or equal to 10, and when am I going to use n is greater than 30, because it makes a difference. Okay, because this is a mean, now we're going to go with n is greater than 30. We established up above that n is 35, so that means 35 is greater than 30, so we're set. This is we can say approximately normal. My sample size is sufficiently large. Okay, then lastly, we're going to go with independent. My sample size can't get too large, otherwise I lose my that probability stability. And in this case, we're going to say that 35 is less than 10% of all MHS students, which is check. We can check that up. We got that, and we got that. So we can put check marks there. We can do whatever we need to indicate that. Okay. All right. I'm wanting to run out of room as far as the A goes. So we'll scooch the name down here a little bit. N stood for name. Again, we might do this from the very beginning, but this is going to be a one sample t-test for means. And again, because this might be a fourth one over here, the standard deviation is unknown. You could go ahead and write in your assumptions just to help you know which to do. Because if the standard deviation is known, then we go over and do a z-test. But because it's unknown, we're going to do a t-test. Okay? All right, so we need a test statistic. Okay? So, again, for the test, just so we have an idea that you have an idea of what's going on, we're going to make you write this out. Okay? So when we see this, we're going to go T is equal to, I observed 5.67 hours of sleep. I'm expecting 7 hours of sleep. We had a standard deviation of 1.88, but because it came from a sample, I have to adjust for that and divide by the square root of 35. And that turns out to be, this is a negative 4.19. Now, yesterday when we talked about the curve, the T curve here, I didn't have you draw it out, but here it is over here at negative 4.19, and we're talking about less than that. So in reality, this should have a pretty small probability. We're not going to be that many standard deviations away. Okay, so remember that because my alternate hypothesis is left, I'm worried about a left-hand tail. If for some reason we had said not equal to 7, then that would mean we'd have some area over here on the right as well. It's a two-tailed test. Okay. All right. So we're going to obtain a p-value. So my p-value is found by taking, again, that's going to be a t, watch that, t CDF of negative 1e99 because it's going left. We're going to go to a negative 4.19. That's my right boundary. And I have 34 degrees of freedom. We could botch ourselves way through the table, but that's no fun because it's not very accurate. So we're going to go second in distribution again. This is where we're going to find our t-CDF, which is option number 6. Negative 1e99 is going to give me my left boundary. What was that? Negative 4.19 is my right boundary. And we had 34 degrees of freedom. So that means we get a p-value of tiny. Okay. Again, make sure if you wrote down 9.36, number one, that should make no sense because our probabilities always have to be between 0 and 1. Okay, so make sure we do that. I'm going to write it out as 0.00009. Okay. Now, let's back up a second. Let's talk about our calculator again, because most of the time I feel like most of you are going to jump straight to your calculator, which is fine. We're going to go to stat. We are going to go over to test, and we're going to conduct a t-test. So we're going to select option number 2. Okay. We don't have data to work with. We are working with statistics. So actually, it looks like I ran this for the keys. So there we go. My null mean was 7. The standard, the X bar, I don't know why that says 5, but we're going to type in 5.67. The standard deviation was 1.88. My sample size was 35. We are testing to be less than the null mean, and we're going to calculate. So as we do this, we can see that we got that t-value. We got a t-value of negative 4.19, which is exactly what we had from our calculator, and we got a p-value of 9.48, 9.49, which is also times 10 to the negative 5th again. So we got that same number as well. Okay, so remember this is just for Mrs. your calculator will spit everything out at you. If you named it, you're okay. You don't have to draw the diagram. You don't have to write the equation. You don't have to do this. You can just go straight to your calculator and write those things down. But for this test, for this chapter, we need to see those things. Okay, when it comes to practicing for when we start practicing for the AP test, we won't worry about making you show those. Okay, all right, now I can finish the problem. So M again stands for make a decision. So since the p-value, and again, make sure you're writing out p-value, because if all you did was write p equals, okay, a p is a proportion, and so we're going to get that confused and not get the right points there. So p-value. And our p-value, we didn't establish what our alpha level was. And it told me up at the very top of the problem that my alpha level was 0.05, but I'll rewrite it. Okay, alpha level is 0.05. So since our p-value is less than alpha, we will reject the null hypothesis. Okay, there is sufficient evidence to suggest, and now we're going to roll to our context and our alternate hypothesis language, to suggest the mean number of hours slept by MHS students is less than 7 hours. Okay, so now we have example number 1 propped out of the way. Okay, so again, notes-wise, we're just going to hit 2 pages at a time. So we're going to grab the example here, example 2, and we're going to roll through it, and then we'll stop the video and let's take a break or whatever you're going to do. You could roll right into the next video for all that matters. That is completely your choice. Okay, alrighty. So a jeweler is planning on manufacturing gold charms. He designed, his design calls for a particular piece to contain 0.08 ounces of gold. The jeweler would like to know if the pieces that he makes contain on average 0.08 ounces of gold. To test to see if the pieces contain 0.08 ounces of gold, he made a random sample of 16 of his particular pieces and obtained the following data. Use a significance test of 0.01 to determine the appropriate hypothesis test. Okay? So, did it or did it not? This is going to be in the form of a yes or no question. Is it or is it not? Okay, so here we go. Again, we got phantoms written out for us because we are doing a hypothesis test. We're going to see a hypothesis test, and now I'm going to do phantoms if we need to do that. Okay. Now, this is a problem where we're given a list of data. Okay. So we have to be able to understand what to do when we see that. So we're going to go to Stat. We're going to go to Edit. And we're going to drop that into a list in our calculator. And I hope, if I remember right, that I still have this in a list in my calculator, because you don't need to see me just type all those numbers in. So there it is. There is list 2. So all of this is stored in list 2. Okay. So again, because I know what I'm doing, I can do, I can use my calculator up front and then just roll with it. But I know that I'm going to conduct a 1 sample t-test because my standard deviation of the population is not known. So we're going to go, as my data is stored in L2, so we're going to go Stat, we're going to go over to Test. We are going to conduct that t-test, except now my t-test is going to come from data, okay? In my data, okay, I haven't written anything down yet. This is when we'll just come back to it. I want to go, it contains on average 0.08, so that is my statement of equality. I'm going to get it to 0.08, okay? List 2 is where my data was stored at, okay? And again, maybe you should write those hypotheses down first, or you just got to think about what we're worried about here. Okay? What does the question ask us? The jeweler would like to know if the pieces that he makes contain on average 0.08. So we're really worried about if it doesn't contain. So it could be if it's less, then he's ripping off his customer. If it's more, he's ripping himself off. So he wants to be near or around 0.08. So this is the one we're going to select not equal to. So it's going to be a 2-tailed test. And we're going to calculate that. So we have everything that we need as far as when we come down here to the test statistic. Okay, I'm going to know, I'm going to have to write it out, but I can write it out now. it's going to be at negative 3.21. Okay? When I go to figure out my p-value, I have to obtain a p-value. The p-value is going to be a TCDF when we do it by hand, but when we get all said and done, my p-value is going to be, and you can't even, I realize now you can't see what I'm writing, my p-value is going to be 0.0058. Okay? So, when we get to all that fun stuff in the end, I have it in my calculator, and we're ready to go. So, also, if I look at my calculator, we can write down some of the things that we're needing to write down as far as my parameters go. Okay? I know that we have a sample mean of 0.079. What did I write down on? Oh, I wrote that all the way up. Excuse me, 0.7798. We're going to leave it at that so we don't have to round off anything, okay? My standard deviation turns out to be a 0.0025. My sample size was 16. So again, we'll get to listing out what my population parameter is. Right now, these are the parameters of the problem, okay? All right, so we've listed all those. We need some hypotheses to go off. So, and actually, it doesn't have to go in order. For example, I know that I already conducted it. It is going to be a one sample t-test, okay? So we're going to go ahead and write that in there. And we just leave it as one sample t-test. Technically, it's 4 means if you want to write that out, okay? All right, so again, phantoms is not going to be written on your paper, so you have your options. You could write out phantoms and just go through and start filling out the blanks. Or you could just start writing down the stuff that you know this problem needs, all right? So we need a null hypothesis. What are we testing against? We were checking to see if the mean weight in gold is 0.08. We're going to test for an alternate hypothesis. And again, we decided already because I don't want to rip off the customer and I don't want to rip off myself, we're going to put that not equal to 0.08. We have introduced a new variable that wasn't there before. It's going to be my mean mu. So that means that we have to define what this is. So the mean is going to be then the mean mu is the true mean weight of gold in the jeweler's gold charms. Okay? Something to that nature. We have defined what that is, so we can go ahead and roll forward. Okay? We got all these assumptions to make, so here we go. We got some space. So the number one assumption typically is going to be a random sample. Of my population, which is gold charms. Do we have that? To test to see if the pieces contain 0.08, he made a random sample of 16. So therefore we have random sample. That's good to go. Number two, approximately normal. So again, because it's a normal calculation, we need to know that it's somehow approximately normal. Typically, we usually run home sample size is greater than 30. Well, we are shot down because we're at 16. So now we have to remember, since we actually have data, if this was a problem that it just gave me 16 pieces and it didn't give me the data, then I would have issues. But now we can go and we can make a box plot. Okay, box plot of number one. It already is set to a box plot. I need to go into graph 2 though and turn it off. Okay, we're going to go to our box plot. Oops, let me get back here to 1. We're going to arrow down here my data. Uh-oh, was it list 2? Somebody tell me. You know, you're not going to be able to. I think it's list 2. So now we're going to go zoom and 9. Oh man, this is no good. No good at all. I'm worried now. Here, let's go check this real fast. Yes, it was list 2. So, we have an outlier. That's no good. All right. Anyway, we have approximately normal. So we have this outlier. We're going to have a gap. Again, we don't have to necessarily have a scale on our box plot, but what we are going to say is has outlier. We're going to PwC this, which again, remember is, I'm not even sure that's actual AP verbiage, but proceed with caution. If I could spell caution. All right, so again, we're going to have to be careful on this one. And number 3 is independent. Did you get too large of a sample? So in this case, 16 is less than 10% of all gold charms. And here again, you're just going to have to make an assumption that he has a pool of over 160 of the same gold charm. Otherwise, we're going to be hurting there on independency as well. Again, your 4th check is optional. Standard deviation is unknown. We would run out and we would this isn't necessary, is what I was trying to say. I don't know where I was talking about running out of anything. All right, so we know that we're going to do a 1-sample t-test for means. We know that we're going to do that. Now, just for our sake, we're going to need the observed. We observed a mean of 0.07798. We expected a mean of 0.8. We're going to divide that by my standard error, which is 0, my standard deviation, divided by my sample size, which is 16. So that number should give me something that's very, very, very close to negative 3.21. Okay. From there, we have to obtain a p-value. From there, we're going to make a graph because you have to on your test. Okay, so here's my graph. We're down here at negative 3.21. Remember, we're going to have 0 in the middle, but that's if we were doing a normal calculation problem, we definitely would want to mark 0 in the middle. Because this is a hypothesis test, it's not too important because you don't have to put a graph at all. We're just wanting you to do it so we can see that you're hopefully understanding the concepts of the likelihood of this event happening, given my null hypothesis was true. So this is going to be found by taking a t-CDF of, since we illustrated the left-hand tail. However, we have to remember that, let's go back up to my my alternate hypothesis. My alternate hypothesis was a not equal to, so that means over here at 3.21, we're going to have an area over here as well. So it doesn't matter which way you go. I'm probably going to go with a negative 1e99 to a negative 3.21, just because the last time I did a t-CDF, it was negative, it was a left. And my degrees of freedom is going to be 15. Okay? So we're going to run to our calculator. We're going to go stat. And again, this is completely unnecessary because I did it on my calculator. So on your test, when you go ahead and take it, you don't need any of this. We don't need to see you calculate the p-value. You did that already. All we need to see is p-value and 0.0058. Obviously, if we were doing this by hand, this is how we're going to get there. Okay? So second in distribution, we're picking option 6. I don't know why you did that. Second in distribution, we're picking option number 6. Negative. This was a what? Negative 3.21. My degrees of freedom is 15. 0029. What? What? Why is this 0029 and I got 0058? I'm saying what as I know what I'm doing. Okay. Remember that this is a two-sided test, so that means we need to take this times 2, and that, you know what? That gives me the 0058. So we were good. Okay, we've done everything right. So now that we've done everything right, we are ready to finish this problem off. We're going to make a decision, and we're going to state a conclusion. So my decision is this. Since my p-value, we have defined what our p-value is in the problem above that. My p-value is 0.0058. Since my p-value is less than alpha, have we established an alpha level anywhere? I just assumed, since it was so small, it's less than alpha. Let's run it to the top and see what we need to write down here. Alpha is 0.01 as it's stated in the problem. Okay, so that means that we're going to, if our p-value definitely is less than alpha, we will reject the null hypothesis. There is sufficient evidence to suggest the mean amount of gold in the charms is not 0.08. Okay. All right. We've got there. And 0.8 actually need to, I'm going to goof this up. Okay. I just about stopped. We don't want to leave that off at 0.08. It's going to be 0.08 ounces. We need to go ahead and grab that. That wasn't in my equation anywhere, or in my sentence. Okay. Now we're good to go. We can stick a fork in it. It is done. So again, I'm going to do blocks of 2 pages. So we hit the end of these 2 pages. So I'm going to stop the recording and have a great day.